Hi everyone, welcome to today's GCSE Maths revision video. There's 3 days to go to your GCSE Maths exam, so keep up the hard work, you're doing really well. And today we're going to be doing a recap of the algebra topic. So we're going to recap the algebra topics that come up in your paper in 3 days time. So let's get started.
Hi, welcome to this recap of the algebra topics on the Corp Maths GCSE Higher Revision checklist. That's the topics in blue. And if you want a more detailed explanation than this quick video, if you go to Ultimate GCSE Higher Revision video and go from 5 hours, 5 minutes and 17 seconds until 8 hours, 40 minutes and 51 seconds, you can get a full explanation of all the algebra topics. But this video is going to be a bit of a faster recap of them. And in terms of the algebra topics, these are the topics that we're going to be going through today. So let's get started. Okay, you also need to be able to collect like terms. So if you're asked to simplify something like this, 8x plus y subtract 3x plus 5y, you would deal with the x's to begin with. We've got 8x's take away 3x's, that's going to be 5x's. And then in terms of the y's, we've got plus y, that's plus 1y, so we've got 1y, and we're adding 5y, so that's going to be 6y's, so plus 6y's. So if we're asked to simplify this, the answer would be 5x plus 6y, and that's it. Also, it's important to know how to expand two brackets. So here, x plus 6 times x minus 2. So we just do x times x, which is x squared. X times minus 2, which would be minus 2x. 6 times x would be plus 6x. And 6 times minus 2 would be minus 12. And then here, minus 2x plus 6x. Well, minus 2 plus 6 is 4. So it'll be x squared plus 4x minus 12. So it's important you know how to expand pairs of brackets. We also need to be able to expand and simplify three brackets. So if we wanted to expand and simplify these, what we would do is we would expand the first two. So we would do x times 2, 5 times x, and 5 times 2. And that would be x squared plus 2x plus 5x plus 10. And then we would still have in brackets our x minus 1. And let's simplify this. That'll be x squared plus 7x plus 10. Just simplifying this. And then we just expand again by multiplying both of these by x squared, multiplying both of these by 7x, and multiplying both of these by 10, and then simplifying, and let's see what we get. So x squared times x would be x cubed, x squared times minus 1 would be minus x squared, 7x times x is plus 7x squared, and 7x times minus 1 would be minus 7x, and finally 10 times x would be plus 10x, and then 10 times minus 1 would be minus 10, and then we just need to simplify this, and if we simplify this, we'd get x cubed. We've then got minus x squared plus 7x squared, that's going to be plus 6x squared. We've then got minus 7x plus 10x, that's going to be plus 3x, and then we've got our minus 10, and that's it. So to expand three brackets, just expand the first two brackets, and then get that answer and multiply by the last bracket, and that's it. So we've looked at how to expand, let's look at factorizing, so that's putting the brackets back in. So if we had 5x plus 20, if we wanted to factorize this, so putting the brackets back in, so we look for any common factors of 15x and 20, and I can see I can divide both of these by 5, so I'm going to put 5 outside the bracket, and then if we divide both of them by 5, 15x divided by 5 will be 3x, and then plus, and 20 divided by 5 is 4. So that's how you'd factorize that, putting the brackets back in, and you can expand to check your answer. In terms of factorizing this, we can divide both of these by 2y. So we would do 2y bracket, and then 4y squared divided by 2y would be 2y plus, and then 6y divided by 2y would be 3, and that's it. So factorizing this would be 2y bracket 2y plus 3. Okay, next, factorizing quadratic. So here we've got x squared plus 8x plus 15. So if you're factorizing this, you can put your two brackets down. Think of when we expanded two brackets, whenever we expanded it, we got something like this. Because of x squared, we're going to put an x in front of both brackets, and then the two numbers in the brackets will multiply together to be 15 and add together to be 8. So that'll be plus 3 and plus 5, because 5 times 3 is 15, and 3 plus 5 is equal to 8. So we're factorized there. In terms of factorizing this, we would do bracket, 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 bracket. We then have x's in the front of both brackets. We want two numbers times together to be minus 22 and add together to be minus 9. So because it's minus 22, the timesing together to give us, so one's going to be positive, one's going to be negative. And then adding together to be minus 9, I'm thinking minus 11 and 2, because minus 11 times 2 is minus 22, and minus 11 plus 2 would be minus 9, and that's it. Okay, next we've got the difference between two squareds. If you got something squared, take away something squared like this, you can factorize it, use two brackets, you then square root each of them and put a plus and a minus sign in the brackets. So here we would have x and x, the square root of 9 is 3 and 3, and one with a plus sign and one with a minus sign. And if you expand your brackets here, you would get this, and that's called the difference between two squareds. We also need to be able to factorize harder quadratics. Now you can use the split in the middle technique, and that's on Corp Maths if you want to watch that, split in the middle. Alternatively, you could just use inspection. So because it's 5x squared, I'm going to go for 5x and x. Now, if it's something harder like 6x squared, you'd have to think, is it 6x and x or 3x and 2x? But in this case, it's quite nice with 5x squared. We can only have a 5x and an x. Now, in terms of the two numbers, they will multiply together to be 6. So I'm thinking if I want it to be 13x in the middle, I'm going to put the 2 there and the 3 there. And let's just check that. 5x times x is 5x squared. 5x times 2 would be 10x. And then we've got our 3x, which is 13x. And then we've got our plus 6. So that's it. Okay, so it's important you can factorize harder quadratics such as that. Okay, if you wanted to solve solve something like this, if you want to solve this quadratic, you just factorize it. So factorize this, and still equal to 0. So then x and x, we want two numbers that times together to be 15 and add together to be negative 8. So because they times together to be a positive and add together to be a negative, they're both negative. And negative 3 times negative 5 is 15. And then if you add these together, you get negative 8. Now we've got two brackets that times together to be 0. So that means that either of the brackets is equal to 0. So one of our solutions will be equal to, well, 3 take away 3 0, so x is 3. And here, if x is equal to 5, that'll be 0, so x equals 5. And there are two solutions, x equals 3 or x equals 5. Okay, next. Also, you might have to factorize and solve harder quadratics such as this. So again, let's put our brackets down, bracket, 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 bracket equals 0. Now again, if you want to use the split in the middle technique, feel free to do that. I'm going to go for 3x and x. Now we want two numbers that will multiply together to be minus 48. Whenever we expand our brackets, we get our minus 10. So I'm going to put the 6 over here so that I've got 3x times 6 would be 18. And I want it to be minus 18 and then plus 8. So let's just check that. 3x times x is 3x squared. 3x times minus 6 would be minus 18x, plus 8x then would be minus 10x, and then 8 times minus 6 would be minus 48. Fantastic. Now in terms of this bracket, x would be equal to 6, and in this bracket we've got then 3x plus 8 equals 0. I'm going to just solve that over here. 3x plus 8 equals 0, minus 8 and minus 8 will give me 3x equals minus 8, and then divide by 3 gives us x equals minus 8 over 3. So x equals minus 8 thirds, or x equals 6, and there are two solutions. Okay, let's have a look at algebraic fractions. So let's simplify this. And if I wanted to simplify this, what I would do is I'd factorize it to begin with. So let's factorize it. So factorizing the numerator, we can take an x out. So that'll be x bracket x minus 2, close brackets. And then on the denominator, if we factorize this quadratic, we would get x and then an x, and then we'll have our minus 2 and plus 4. And let's just check that. Yeah, that expands to be this. Now in terms of simplifying our algebraic fraction, we can divide both the numerator and the denominator by x minus 2. So that would then cancel out. So then that would leave us with x over x plus 4. So it's important you can simplify these algebraic fractions, and that's it. Also, you need to be able to multiply algebraic fractions. And think back to multiplying fractions, you just multiply the numerators and multiply the denominators. So in terms of this one, you would have 3x times 5x is 15x squared over 2 times 6 is 12. And in terms of this, we can divide both the numerator and denominator by 3, so it'll be 5x squared over 4. Now in terms of this, we could multiply them together first of all and get, so we multiply the numerators and multiply the denominators, and it'll give us this, just putting them beside each other. And then what we can do is we can divide both the numerator and the denominator by x plus 4. So that would leave us with x minus 3 over x plus 1, and that's it. Okay, and then in terms of dividing algebraic fractions, what we do is we just multiply by the reciprocal. So we'd have our 3x plus 9 over 2 multiplied by, and the reciprocal of this would be 4 over x plus 3. And then we just multiply the numerators together and multiply the denominators together. And then you can factorize and cancel down and so on as well. And that's it. So whenever you're dividing with algebraic fractions, just remember to multiply by the reciprocal. Okay, next, adding algebraic fractions. So whenever you're adding algebraic fractions, you need to make sure you have the same denominator, just like adding normal fractions. So here we've got 3 and 2 in the denominator, so we want to get 6 and 6. So to get from 3 to 6, we multiply by 2. So we multiply the numerator by 2, we'd have 2x plus 8. And here we've multiplied the denominator by 3, so if we multiply the numerator by 3, we'd get 3x plus 3. And now we've got two fractions with the same denominator, so we can just add them. So if we add the numerators, we'd have 2x plus 3x is 5x, and 8 plus 3 is equal to 11. So that'll be 5x plus 11 over 6. And that's it. Okay, now you may also encounter algebraic fractions with equations. You may have these equations with algebraic fractions involved, and then you actually just use the same approach. So in terms of this one, you would get two fractions with 6 on the denominator, and it still equals 8. And then what you do is you add together and simplify that left-hand side, and it equals 8. And then what you do is you just solve that equation, and then you can find the value of x. And then in terms of this one, what you need to do is multiply both the numerator and denominator of this fraction by that denominator, and multiply both the numerator and denominator of this fraction by that denominator, and simplify this left-hand side, and it's still equal to 2. And then you solve that equation. Then you'll find your value or values of x for that one, and that's it. Okay, next, the nth term. So here we've got 4, 9, 14, 19. As you can see, we're getting bigger by 5 each time. So in terms of numbers that are getting bigger by 5 each time, I'm thinking of the multiples of 5. 5, 10, 15, 20. And so I'm going to write 5n, because 5 times 1, 5 times 2, 5 times 3, and so on. Now our sequence wasn't 5, 10, 15, 20. It's actually one less. We're taking away 1, taking away 1, taking away 1, taking away 1. So the nth term for our sequence would be 5n minus 1. Now this is really useful. We could find the 100th term. We could do 5 times 100, which is 500. Take away 1, which would be 499, and so on. Someone may give me a number number, for instance 477, I can tell straight away 477 is not going to be in this sequence because it always ends in a 4 and a 9 and a 4 and a 9 and so on. But you could put your nth term equals to the number, and then if you solve that equation and get a whole number, it's in the sequence, but if you get a decimal number, it's not in the sequence, and so on. So the nth terms are really useful, so it's important to know how to work them out and how to use them. Okay, so we've looked at nth term for linear sequences. Now let's have a look at quadratic sequences. There's a few different ways you can find the nth term for quadratic sequences. In this video, I'm just going to show you one approach. So what I would do is I'd find the first differences for the sequence. So that would be 11. It's going up by 11. It's going up by 15. It's going up by 19, and it's going up by 23. And then I would work out the second differences, which would be 4, 4, and 4. So we've got the first differences and the second differences for this quadratic sequence. Now in terms of finding the nth terms, so it's a quadratic sequence, so the nth terms in the form an squared plus bn plus c. And that's the nth term. We just need to find the values of a, b, and c. So in terms of the second difference, that's equal to 2a. So you're going to get that 2a equals 4. So then you'd get that a is equal to 2. So you could find that. The first difference, this one is equal to 3a plus b. So once you know that a is equal to 2, then you can substitute that in here and get 3 times 2 is 6. So then you'd have 6 plus b is equal to 11. So b is equal to 5 there. And then finally, the first term of the sequence is equal to a plus b plus c. And because you know the values of a and b, you can then find the c quite easily, and that'll give you the quadratic nth term. Okay, and in terms of substitution, you may also be given situations in a bit of a context. So here we've got Erin's cooking a turkey. This isn't an accurate formula, by the way, so don't try and use it to cook a turkey. But we've got the cooking time is equal to 90 plus the weight of the turkey in kilograms times 20. And the question says, how long should it take to cook a 7 kilogram turkey? So the weight of the kilogram is 7, so you're going to do 7 times 20. Remember your bod mass, 7 times 20 is 140, plus 90 would be equal to 230. So that would take 230 minutes. You may also be given a question where you're told the cooking time and you need to find the weight of the turkey. And in that case, you can work backwards. So you could take away 90 and then divide by 20, or you could set up an equation and solve it. And that's it. Now, in terms of formula solving equations, there's a load of different questions that you may encounter in terms of formula equations. Now, in terms of this question, if we were asked to find x here, what we would do is we'd have to form an equation. And because this is an isosceles triangle, these two angles are the same. So here we've got our isosceles triangle of a line of symmetry, so these two angles are the same. So if this angle is x plus 20, this angle here would be x plus 20. And now we can form an equation because we know that these three angles must add together to be 180. So 2x plus x would be 4x's. And then we've got plus 20, that'll be plus 40. And then that's equal to 180 because the angles in a triangle add together to be 180. And then you can just solve this. We could take away 40 from both sides, and that would leave us with 4x equals 140, and then we could divide by 4 and get that x is equal to 35 degrees, and that's it. Okay, that's how you'd form and solve that equation. And as I said, these practice questions and videos will be very useful for you. Okay, next, changing the subject. So sometimes you have to make a certain letter the subject of something. So here we've got t equals aw subtract c, and we've been asked to make w the subject. So that means you want w equals. So it means that you want to get rid of everything else on this side, this right hand side, and just leave w. So let's get rid of the minus c to begin with. So let's add c to both sides to get rid of this minus c. T plus c would be t plus c. And on the right hand side, you're adding c to get rid of the minus c, so you just be left with aw. This is now a times w. You don't want this multiplied by a, you just want to get the w, so we're going to divide by a and divide by a. T plus c divided by a, well, it's going to be t plus c and then divided by a, and that's equal to w. And that's it, we've made w the subject. W equals t plus c divided by a. So it's a bit like solving equations, but you don't actually have to work anything out, so I actually like changing the subject. Okay, so we're changing the subject. You may encounter some more complex question. So here we've got make y the subject of this, and as you'll notice, we've actually got two y's. So if you encountered something like this, what you would want to do is get these y's off the denominator. So what we would do is we'd multiply both sides by y plus 5, and then on the left hand side we'd have w bracket y plus 5, and then on the right hand side we multiply by y plus 5 to get rid of the divide by y plus 5, so we'd just be left with y plus 2 on the top. So then we'd then expand our brackets. W times y would be wy, and then w times 5 would be plus 5w, and that equals y plus 2. Now we want to bring all the y's to one side and then everything else to the other side. So that's minus y and minus y. So now let's go up this way. So we've got wy plus 5w, and then we're going to have to take away y on the left hand side. On the right hand side we had y plus 2. We're taking away y, so we'd just be left with 2. Now we wanted to have all the y's on this left hand side, so let's get rid of this 5w here because it doesn't have a y there, so if take away 5w and take away 5w. So on the left hand side we'd have wy minus y, and on the right hand side we'd have 2 minus 5w. Factorize this, so we'd have y bracket w minus 1, close brackets, equals 2 minus 5w. And then finally, we want the y on its own, so let's divide both sides by w minus 1. So then the left hand side would be left with y, and the right hand side would have 2 minus 5w over w minus 1, and that's it. Okay, now just before we move on to inequalities in a bit more detail, let's just make sure we know what inequalities are, identities, equations, and expressions. So here's a question that says circle the identity. Well, here we've got an equation, so this is an equation because we've got 4x plus 1 equals 21. That's an equation. You can solve and get an answer. This is an inequality because it's got the less than or equal to symbol. This is just an expression, 6x minus 8, that's an expression. And then this, 5 bracket x plus 1 close brackets, is equivalent to 5x plus 5. So this left-hand side is always equal to the right-hand side, so that's an identity, so I'd circle it. Okay, next, solve an inequality. So you may encounter an inequality like this, 3x plus 4 is less than or equal to 31, and you solve this just like an equation, so take away 4 and take away 4, and you get that 3x is less than or equal to 27, and then divide by 3 and divide by 3, and you get that x is less than or equal to 9, and that's it. That's how you'd solve that inequality. Now also with inequalities, you may encounter graphical inequalities. So you might have a question like this, where we've been asked to show the region that satisfies inequalities. X is less than or equal to 7. So you draw the line x equals 7, this vertical line, and it's less than or equal to 7, so it means it's going to be on the left-hand side of that vertical line. Then we've got y is bigger than 3, so because it's just bigger than, we do a dashed line. So if you ever see bigger than or equal to or less than or equal to, it's a solid line. If it's bigger than or less than, it's a dashed line. So it's y is bigger than 3, so we do a dashed line at 3, and bigger than means it's above the line, so we know it's above this horizontal line, and it's to the left of this vertical line. And then we've been told y is less than or equal to a half x plus 2. So we draw the graph of y equals a half x plus 2, that diagonal line. It says it's less than or equal to, so I would choose a point that's not on the line, such as the origin, and I would substitute the origin into this. And if I substitute the origin into it, so remember the origin is the point 0, 0. If I substitute it into this, y, which is x and y, so we would have 0 is less than or equal to a half of 0, which is 0 plus 2. And 0 is less than or equal to 0 plus 2. So this side works, so that means that we want below the line, so this shaded region would satisfy those inequalities. So make sure you're confident with graphical inequalities. Okay, next, quadratic inequalities. So you may need to solve quadratic inequalities. So if you've got an inequality that's a quadratic, what I would do is I'd make one side 0 and have the quadratic on the other side. And then what I would do is I would sketch the quadratic. So here we've got solve x squared plus x is less than 12. So I'd sketch that quadratic to begin with. So the graph y equals x squared plus x minus 12. So sketch that graph to begin with. So I draw a set of axes. So in terms of sketching this quadratic, it's an x squared quadratic, so we know it's a U-shaped parabola. So to sketch it, what I want to really do is find out where it crosses the x-axis. To find out where it crosses the x-axis, I let y equal 0. So I'd get 0 equals x squared plus x minus 12. And if I solve that, we'd get x equals 3 or x equals minus 4. So we've solved that, so we now know where it crosses the x-axis. It crosses the x-axis at minus 4 and 3. So let's sketch our quadratic. It's a U-shaped parabola, and it crosses through minus 4 and 3 on the x-axis. Now we want to find where that quadratic is less than 0. In other words, when is that quadratic below the x-axis? And it's below the x-axis for values of x between minus 4 and 3. So that's our answer. X is bigger than minus 4 and less than 3. And that's it, that's our answer. If you had a quadratic inequality like this, again, let's sketch the quadratic. Okay, so I've just sketched the quadratic because I know it's a U-shaped parabola, and I put the quadratic equal to 0 and I solved it and found that across the x-axis at minus 5 and 3. So I've sketched the quadratic. We want to find when it's bigger than 0. So in other words, when is this quadratic bigger than 0? So this quadratic is bigger than 0 above the x-axis for values of x that are less than minus 5. So x is less than minus 5. So here, anything that's less than minus 5 is above the x-axis. And any value of x is bigger than 3, so or x is bigger than 3, and that's it. We've solved that quadratic inequality. Okay, next, drawing linear graphs. I'm actually going to start off with this one. If we were asked to draw the graph of x equals 2, so that would be the line x equals 2. So if you've got an x equals graph, x equals 4, that'll be a vertical line going through 4. If you had x equals minus 3, that'll be a vertical line going through minus 3, and so on. Now, if we wanted to draw y equals negative 1, we would draw a horizontal line through negative 1 on the y-axis, because all of these points would have a height of minus 1, so it would look like this. So that would be the line y equals minus 1. If you're asked to draw y equals 3, it'd be a horizontal line going through 3 on the y-axis, and so on. So it's important to be able to draw those x equals graphs and y equals graphs, not only for this topic, but also for reflections, because you may often have to draw the mirror line. And then if I want to draw this graph, y equals 2x plus 1, the approach I probably would use is I'd probably just use a little xy table. I would choose some values of x, 0, 1, 2, 3. And to find the y coordinate, we multiply all the x coordinates by 2, and then add 1. So if we multiply this by 2, 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6 plus 1 is 7. And then you just plot those points. And that would be it. That would be the graph of y equals 2x plus 1. And that's it. Now there is another approach, and I'll talk about that in a second. That's where you use the gradient and the y-intercept. So I knew that this graph was going to cross the y-axis at 1, and it's got a gradient of 2, where you go across 1 unit and up 2 units, across 1 unit and up 2 units, and so on. Okay, so in terms of that, y equals mx plus c. So this is the equation of a line, y equals mx plus c, the equation of a straight line. So m's the gradient, how steep the line is, and c is the y-intercept. So if we had a look at this line here, this diagonal line here, its y-intercept is equal to 1 because it crosses the y-axis of 1, so it'd be plus 1, as you can see. In terms of its gradient, to work out its gradient, you do rise divided by run. So you choose 2 points on the graph, you draw a little triangle like this, and you work out the run. So as you can see here, we're going 2 across, and we're going up 4 units. And if we do 4 divided by 2, that's equal to 2. So the steepness of this line is 2. As we go across 1 unit, we go up 2. As we go across 1 unit, we go up 2. So its gradient is 2. So it's y equals 2x plus 1, and that's it. So that's the equation of that line, y equals mx plus c. Okay, so you may also encounter straight line graphs in real life situations. So here's the cost of hiring a bouncy castle for a number of days. So we've got 0 days is £100, so that's like a set fee, a set charge for hiring the bouncy castle. And then we've got 2 days is £150, 4 days is £200, 10 days is £350, and so on. So maybe ask questions involved in these. For instance, how much does it cost to hire the bouncy castle for 5 days? So you go 5 up and across and see that's £225. You may be asked the question, how much is the set charge for hiring the bouncy castle, or perhaps the delivery charge or the setting up charge or something like that. And in this case it's £100, and you can find that by going to 0 days and seeing that number. And you may also be asked to find the cost per day, and you can do that in a couple of ways. One approach is to find the gradient of the line, so to find 2 points such as this point and this point, and do your rise divided by run, so turn it into a little right angle triangle, and do the rise, which is £250, it rises £250, and the run is 10 because it's 10 days, and 250 divided by 10 is £25, so it's £25 to hire per day because the gradient of the line is 25. Or you can just have a look and see that for an extra day it's £25, another day it's £25, another day it's £25, and so on. So that's how you'd answer those questions involving real life graphs. Now, whenever we're dealing with linear graphs, sometimes we need to find the midpoint of a line. So if you wanted to find the midpoint of the coordinates a and b, all I would do is just add them together and half it. So I'd add the x coordinates together. 5 plus minus 7 is minus 2, and then minus 2 divided by 2 is equal to minus 1, and then 4 plus 11 is 15, and half of 15 would be 7.5. So the midpoint of that line would be minus 1, 7.5. Now sometimes you might need to find the distance between 2 points. We've got the point A and B. If we want to find the distance between them, we use Pythagoras' theorem. So just turn it into a right angle triangle. So you turn it into a right angle triangle. Here we know that in terms of going across, it's going from minus 1 to 3. So it's going to be going 4 across. And in terms of the rise, it's going from minus 4 up to 0. So again, that's 4. And then you just use Pythagoras' theorem, and that's it. Now sometimes we might need to find the equation of a line that passes through 2 points. So if we want to find the equation of the line that passes through these points, remember it's a straight line, so it's going to be in the form y equals mx plus c. Let's find the gradient of the line to begin with, so we're going to do rise over run. Now sometimes a little sketch can be useful. So 3, 8 would be there, so 3 across 8 up, and 5, 20, well 5 across and 20 up would be a bit higher, it would be there, and so that's the point 3, 8, and that's the point 5, 20, and then we join them up. And if we wanted to find the gradient of that line, remember we just do a little right angle triangle, and we do rise over run. In terms of the run, we're going from 3 to 5, so the run's 2. The rise, we're going from 8 up to 20, the rise would be 12. And the rise divided by run, 12 divided by 2 is equal to 6. So the gradient of that line is 6. So we'd have y equals 6x plus c. Now to find where this line crosses the y-axis, the plus c, what I would do is I would just choose one of the points. So I'm going to choose this one. I'm going to call that x and y, and I'm going to substitute those into our equation. So y is 20 equals 6x, 6 times 5 is 30, plus c. If we take away 30 from both sides, we get c is equal to minus 10. So the equation of this line would be y equals 6x minus 10. And that's it. So that's how you find the equation of that line. Okay, next, parallel lines. So we talked about y equals mx plus c. If lines have got the same gradient, they've got the same steepness of each other. So that means that they're going to be parallel. So the line y equals 2x plus 1 and the line 2x minus 3 are parallel lines because they've both got a gradient of 2. And as you can see, they've both got a steepness of 2, so they're parallel to each other. So parallel lines have got the same gradient. Okay, so we've looked at parallel lines. Let's have a look at perpendicular lines. So if you've got 2 lines that are perpendicular to each other, the gradients will multiply together to be -1. And what that means is, if you know the gradient of one of them, you can do the negative reciprocal of that to find the gradient of the other one. So if, for instance, the gradient of one of the lines was 2, then when we do the negative reciprocal of that, well, the reciprocal of 2, well, 2 is 2 over 1. When we flip it over, that's 1 over 2. And the negative reciprocal will be -1/2. So that means that a line with a gradient of -1/2 will be perpendicular to a line with a gradient of 2. And as you can see, these two lines are perpendicular to each other. They cross each other at 90 degrees. And that's it. So if you know the gradient of a line, if you want to find the gradient of the line perpendicular to it, you do the negative reciprocal of the gradient. Okay, next, simultaneous equations. So if we want to solve simultaneous equations like this, what we'd want to do is eliminate one of the letters. So here, what we could do is we could times the top equation by 2 and the bottom equation by 3, and that would give us 6x and 6x. And then if we take 6x away from 6x, we're left with 0. And so that means that it's eliminated. Or what we could do is we could just times the top equation by 3 to get minus 3y and 3y, because minus 3y plus 3y is 0. So in terms of simultaneous equations, you want to cancel out one of the letters. So I'm going to times the top equation by 3, so that'll give me 9x minus 3y equals 69. And then we've still got the bottom equation, which is 9x plus 3y equals 8. Now we wanted to cancel out one of the letters or variables, and here what we're going to do is we're going to cancel out the y's, because minus 3y plus 3y is 0. So let's add these two equations to each other. So let's add 9x plus 2x is equal to 11x. Minus 3y plus 3y is equal to 0, so that's just 0. And then we've got 69 plus 8 is equal to 77. And then you just solve that, divide by 11, you get x equals 7. So you get x equals 7. And then I'm just going to take the x equals 7 and substitute into one of the other equations. So I'm going to substitute into this bottom one. 2 times x, so 2 times 7 is 14. So I'd have 14 plus 3y equals 8. So 14 plus 3y equals 8. And then if we solve this, we can find y, and then we'll find our x and our y. So if we take away 14 and take away 14, we get that 3y equals minus 6, and divide by 3 and divide by 3, and you get that y is equal to minus 2. And then you can check this if you substitute these both into the top one and substitute in x equals 7 and y equals minus 2, you should get 23 as the answer, and then you'll know you're right. Okay, you can also solve simultaneous equations graphically. So here we've got y equals 3 minus x and y equals 2x minus 3. If you draw both those lines, and where those two lines cross each other will be your solution. The x coordinate will be the value for x, and the y coordinate will be the value for y, and that's it. So to solve simultaneous equations graphically, just draw the lines and write down where they meet each other. Now it's also important to be able to solve nonlinear simultaneous equations. So here we've got a quadratic and a linear, so this is a nonlinear. And if we wanted to solve these simultaneous equations, if it's just y equals and y equals, you can just put them equal to each other. So if I wanted to solve these simultaneous equations, I would just put them equal to each other. So I'd write x squared plus x minus 14 equals x minus 5. So those ones are quite nice because it's y equals and y equals. And then I would just solve that, find the values of x, and then I would substitute them back in to find the values of y. And that's it. So that one's quite nice. Now also with nonlinear simultaneous equations, you might encounter questions like this where they actually ask you for the coordinates of the points of intersection, and that just means solve the simultaneous equations and your solutions will be the coordinates. And in terms of solving something like this where we've got y equals x plus 3 and x squared plus y squared equals 149, because we've got y the subject of this one, we would just substitute this in for the y here. So we would have, if we substituted this into here, replace the y with x plus 3, we would have x squared plus, and instead of y, we're going to put brackets x plus 3, close brackets, squared. Now that's equal to 149. And then we just solve this. We would write that bracket out twice, expand those brackets, simplify, get it equal to 0, solve it, find the values for x, then put them back in and find the values for y, and then write them as coordinates, and then that's your answer. And it's also important you know the equation of a circle. So the equation of the circle at GCSE level is x squared plus y squared equals r squared, where the center of the circle will be the origin, the point 0, 0, and the radius of the circle is r. So here we've got x squared plus y squared equals 16. Because it's r squared, that means if you square root that, you get 4. So that means the radius of the circle is 4 and the center is the origin, 0, 0. And so it's important you know the equation of a circle. It's also important to be able to, for instance, answer questions where you might need to find the radius of the circle if you're given the equation. You might need to be able to find the circumference of a circle if you know its equation, or the area of the circle if you know its equation, and so on. Okay, next. You might also need to be able to find the equation of a tangent to the circle. So if you've got a circle, such as this circle here, and you know there's a tangent at a particular point, and they wanted you to find the equation of that tangent. Remember that tangent's a straight line, so it'll be in the form y equals mx plus c. So you would need to find the gradient and the y-intercept for this straight line. And to do that, what I would do is I would first of all consider the radius of the circle, because the radius and the tangent will always meet at 90 degrees. So find the gradient of the radius. As you can see here, this radius has got a run of 2 and a rise of 6. 6 divided by 2 is 3. So the gradient of that line is 3. So you do the negative reciprocal of that to find the gradient of the perpendicular line. Once you do the negative reciprocal of that, that'll be your gradient. You'll then have y equals something x plus c. You know it passes through the point 2, 6, so you let x equal 2 and y equal 6. You substitute those in and you find your c. And then that's how you'd find the equation of that tangent to that circle. You may also encounter instantaneous rates of change. So in terms of rates of change, you might have a graph such as this, and you might need to, for instance, here it says estimate the rate of change of the depth of water at 2.5 seconds. So what I would do is if you wanted to estimate the rate of change of this graph at 2.5 seconds, you draw the tangent to that point, and then you find the gradient of that tangent. So you just do your rise over run. So you just choose 2 points on that tangent. So for instance, I could choose this point here and I could choose this point here. You choose 2 good points, and then you just then turn it into a right angle triangle and do your rise over run. In this case, the rise would be negative, so you do your rise over run, and that will give you the gradient of the tangent, which is your estimate for the rate of change. So to find the rate of change at a particular point, you just draw a tangent at that point, and you find the gradient of it. And sometimes you might encounter rates of change question that rather than asking you for the rate of change at a particular point, it says here, estimate the average rate of change of the depth of water between 1 second and 6 seconds. So in that case, what you do is you plot the point at 1 second, you plot the point at 6 seconds, you join them up, and then you find the gradient of that chord that joins up those points. And the gradient of that chord will be the average rate of change between that point and that point. And that's it. You may also encounter questions which involve area under a curve. So here we've got a curve, and then part A says find an estimate for the distance traveled by the bicycle in the first 12 seconds. So this is a speed time graph. If you find the area under a speed time graph, that's the distance. And it says for the first 12 seconds, that's from here to here. So you want to find the area under that curve for that region there. And it says use 3 strips of equal width. Now, because it's from 0 to 12, if we divide that by 3, then that would be 4. So we're going to do strips that are 4 seconds wide. And then we join up those points to give us a triangle, a trapezium, and a trapezium. And then you find the area of the triangle, the area of the trapezium, and the area of the trapezium. And then whenever you get those 3 areas, you add them together, and that'll be the estimate for the total area under that curve. And that's how you do part A. And then part B says, is your answer to an underestimate or overestimate? If you look here, our chord is above the curve. So that means we've worked a slightly bigger area than it really is. So that means our answer would be an overestimate in this case. And that's it. Okay, now you may encounter functions, and so here we've got a function of x is equal to 8x minus 7, and we want to find the inverse function. Now if you want to find the inverse function, what I do is I take the function that you've been given, and I let that equal y. So I write down y equals 8x minus 7, and then what I'm going to do is I'm going to make x a subject, and then if I make x a subject, that'll help me find the inverse function. So if I wanted to make x a subject, I'd add 7 to both sides, so add 7 and add 7. So the left hand side would become y plus 7, and the right hand side would just become 8x, and then I would divide by 8 and divide by 8, so divide by 8 and divide by 8. So the left hand side would be y plus 7 over 8, and the right hand side would just be x. So that means that we've got x equals y plus 7 over 8. So this will be our inverse function. So we'd write that down. We'd write the inverse function of x is equal to, and instead of writing y plus 7 over 8, I'm going to replace the y with an x, so x plus 7 over 8, and that's it. So if you want to find an inverse function, just take the function you've been given, let it equal y, make x the subject, and then that'll be your inverse function. Just replace the y with an x. Now also, whenever we're dealing with functions, you may encounter composite functions. So here we've got a function of x, f of x is equal to 2x plus 1. And we've got another function of x, g of x equal to x squared plus 5. So if we wanted to find fg of x, we would have our x, we'd apply the function g to begin with, so that would give us x squared plus 5. And then we'd apply function f, so we would then substitute that into function f. So fg of x would equal 2. And then instead of x, we're going to write our x squared plus 5, so x squared plus 5, close brackets, and then plus 1. We'd expand our brackets to give us 2x squared plus 10 plus 1, and that'd be equal to 2x squared plus 11. So that would be the function fg of x. If we wanted to find gf of x, we'd start off with x, we'd apply function f, so that'd be 2x plus 1, and then we'd apply function g, so we'd substitute this into g. So that would be gf of x would be equal to, instead of x squared, we're going to write 2x plus 1, close bracket squared, and then plus 5. We then write that bracket out twice. We then expand those brackets and then add 5 and just simplify that, and that'll be the function gf of x. Okay, next, quadratic graphs. So quadratic graphs is very important. You can draw a quadratic graph. So you may be given an equation such as y equals x squared plus x minus 4, and then you're asked to draw the quadratic graph. And you may have an xy table, perhaps even with some of the values filled in for you, and that's quite nice. And then, so here, if we wanted to work out the y coordinate, so we're going to take the x coordinate. So here we're going to take 3. We're going to square it. We're then going to add 3, because we're adding x, and then we're going to take away 4. So we do 3 squared plus 3 minus 4. 3 squared is 9, so you've got 9 plus 3, take away 4. 9 plus 3 is 12, take away 4, and that's equal to 8. So this would be 8. You would then do 2 squared plus 2, take away 4. 1 squared plus 1, take away 4. 0 squared, which is 0, plus 0, take away 4, which would be minus 4. You would then do minus 1 squared. Remember, a negative times a negative is a positive, so minus 1 squared is 1. Adding minus 1 means you're going to go back down 1, which would be 0, and then take away 4, which would be minus 4. So negative 2, you would do negative 2 squared plus negative 2, take away 4. 4 plus negative 2, well, going down 2 would be 2, take away 4 would be equal to negative 2. So it's going to be negative 2 and so on. And I've just filled in the other points as well. And then once you get your points, just plot them. And that's it, that's our quadratic graph. And in terms of our quadratic graphs, they'll have that U shape. If it's an x squared quadratic, it'll have a U shape. If it's a minus x squared, it'll have an N shape. So it'll have that U shape or N shape. And it'll have a line of symmetry as well. And actually we can see that with our points, minus 4, minus 4, minus 2, minus 2, and so on. And that actually can sometimes help you to fill out the table. And that's it. Okay, next. Now it's also important you know the shapes of the trigonometric graphs. So the graph of y equals sine x would look like this. The sine of 0 is 0. The sine of 90 degrees is 1. The sine of 180 degrees is 0, the sine of 270 degrees is minus 1, and the sine of 360 degrees is equal to 0. And I would just carry on. So this is the sine x graph. It would start at the origin, go up to 90 and 1, and so on. This is the graph of y equals cos x. So it starts at 0, 1. So cos of 0 is 1. The cos of 90 degrees is 0. The cos of 180 degrees is minus 1, and so on. And I would just carry on in that shape. And it's important you know the shapes of those graphs. And then we've got the graph of y equals tan x, and it would look like this. So it's got asymptotes at 90 degrees and 270 degrees. It starts at the origin and then curves upwards and shoots up, and then it comes up, passes through 180 degrees and 0, and curves up and so on. And it's got that shape, and that's the tan x graph. And it's important you know what these trig graphs look like. Okay, next. Now in terms of other graphs, another type of graph you may encounter is the cubic graphs. This is a cubic graph here. So make sure you're able to substitute values for x and find values for y and be able to plot and draw those cubic graphs. Also make sure you know the shape of the y equals x cubed graph. So it looks something like this. So that would be the shape of the y equals x cubed graph, where it passes through the origin, then it gets very steep very quickly, and it goes down very quickly as well. And also make sure you know the shape of the y equals minus x cubed graph as well. And then that would be the shape of y equals minus x cubed. So make sure you're able to plot cubic graphs and you know the shape of y equals x cubed and y equals minus x cubed. Okay, and you may also encounter reciprocal graphs, and that's where you've got, for instance, here we've got y equals 2 over x, where the x is on the denominator. So you just need to, whenever you substitute in the values for x, you're going to do 2 divided by 5, 2 divided by 2, 2 divided by 1, and so on. So let's work those out. And that's it. And the curve will look something like that. Now, apologies, not necessarily the best one. I'm trying to do this on the computer. It should be a nice smooth curve through those points. The graph will approach the x-axis but never reach it, and it'll approach the x-axis there and never reach it. And likewise, it'll approach the y-axis and never reach it as well. And that's the reciprocal graph. Okay, next, exponential graphs. So exponential graphs, they get very big very quickly. So we've got y equals 2 to the power of x. Well, as we know, 2 to the power of 0 is 1. 2 to the power of 1 is 2, 2 squared is 4, 2 cubed is 8, and it gets very big very quickly. In terms of the negative values of x, so 2 to the power of negative 1 would be 1 over 2, or a half. 2 to the power of negative 2 would be a quarter, because 1 over 2 squared is a quarter. 2 to the power of negative 3 would be an eighth, and so on. Okay, next. Okay, next, you may encounter geometric sequences. So geometric sequences are, rather than adding or subtracting the same amount each time, we're multiplying by a common ratio. There's a certain number that you're multiplying by each time. As you can see here, we're multiplying by 2, multiplying by 2, multiplying by 2, and so on. So it could be that you're timesing by 2, or timesing by 3, or even timesing by half, and that means that each time the numbers are halving, and so on. So that would be a geometric sequence where we're multiplying by the same number each time. Another thing to note is if we divided the second term by the first term, we get 2. That's what we're multiplying by each time. If we divide the third term by the second term, we get 2. If we divide the fourth term by the third term, we get 2, and so on. So if you divide a term by the previous term, you'll always get the common ratio of that number you're multiplying by each time. And that's going to be quite useful, because if you've got perhaps algebra involved, if you divide a term by the previous term, that'll be the same as another term divided by the one before it, and so on. So that might just become useful whenever you're dealing with geometric sequences. Now, another topic you may encounter is algebraic proof. So you may need to prove something. So here's a question. It says, prove the sum of 4 consecutive odd numbers is always a multiple of 8. So in terms of even numbers and odd numbers, if we had n could be either odd or even, but if we multiply by 2, that will always be even. So 2n is what I would use to represent an even number. And then I would add 1 to get an odd number, 2n plus 1, that would be an odd number. So this would be an even number, even, and this would be an odd number. Now here the question says prove the sum of 4 consecutive odd numbers. So the first odd number I'm going to choose is 2n plus 1. The next odd number would be 2n plus 3 because plus 2 would be even, so plus 3 would be the next odd number. The next odd number would be 2n plus 5 and the next odd number would be 2n plus 7. The sum of them, we would add all this up, that would be 8n plus, then 1 plus 3 is 4, plus 5 is 9, plus 7 is 16, so plus 16. And then if we want to show this is a multiple of 8, well, let's just factorize and take 8 out, and that would be n plus 2. So it's 8 times something, so therefore it's a multiple of 8, and you just write that down, and that's it. So an even number, I would use 2n, an odd number, I would use 2n plus 1. And if you want to show something's perhaps a multiple of 8 or 7 or 4, just factorize it and take that number out as a factor. Okay, next, the quadratic formula. So in terms of solving quadratics, we can solve quadratics by factorizing and solving, and we looked at that earlier. Another approach you can use to solve quadratics is use the quadratic formula. So if you've got a quadratic equation where you've got it equal to 0, the coefficient of x squared is a, so the number in front of the x squared is a, the coefficient of x is b, and the number on the end, that constant, is c. And then we would use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And the good news is that's given to you. So what I would do is I'd write down the values for a, b, and c, and then substitute them in, and then solve it and get your values of x. So in this case, if we're asked to solve this, a, the coefficient of x would be 2. B, the coefficient of x here, well, in front of it we've got minus, that's minus 1x, so that means that b is equal to minus 1, and c is equal to minus 9. So we've got our values for a, b, and c, and then we just substitute them into the quadratic formula and find the values of x, and that's it. Now, another technique we can use to solve quadratic equations is completing the square, and this technique is actually quite useful for other things as well, such as finding the turning points of quadratic graphs. So here, if we were asked to write x squared plus 6x plus 1 in the form x plus a, close bracket, squared plus b, what I would do is, first of all, open up the brackets, and then write x. And then here, look at the number in front of the x term in the middle, that's 6, so we half that, so that's 3, so we then write plus 3, so half the coefficient of x and put it in the bracket. Close brackets and then do squared. Now what we're going to do is take away this number squared. 3 squared is 9, so we then take away 9 and then we put this number on the end, plus 1. And then we just simplify this, so we'd have x plus 3, close bracket, squared, and then minus 9 plus 1, going back up 1 would be minus 8. And that would be it. So we've written this in this form. And then if this was a quadratic equation equal 0, you would add 8 to both sides, you would then square root, and then you would take away 3, and then that would give you your values for x. You could even use this to find the turning point of a quadratic graph and so on. So that's how you do completing the square. Okay, next, transformations of graphs. So if you've got the graph of y equals f of x, so if you've got the graph of a function of x, then you need to know these 4 different transformations of graphs. So you've got y equals minus f of x, that's a reflection in the x-axis. Y equals f of minus x, that's a reflection in the y-axis. Y equals f of x plus a, that shifts the graph, a squares upwards, so it's a translation, a upwards. If it was minus a, it would then translate it a squares downwards. And if you've got y equals f of x plus a, where the plus a is inside the brackets, this would translate the graph a squares to the left. If it was minus a, it would translate it a squares to the right, and so on. And that's it. So it's very important you know those transformations of graphs. And finally, you may also encounter iteration. So here's an iteration formula, xn plus 1 equals 5 minus 2 over xn, and then you've been asked to start with x0 equals 4. So what you would do is you take this 4 and you substitute it in for xn. You then work that out. That would give you x1. You then get that value. You substitute it in here, and then you get x2. Then you get that value, substitute it in here, and you get x3, and so on. So it's important you're able to use an iteration formula, but it's also important to do other things in iteration questions as well. So for instance, you may be given an equation and may be asked to rearrange it into a particular form. It might be that you're asked what these represent, so they are increasingly accurate approximations to a solution to a particular equation, and so on. So I would actually recommend the videos and the practice questions for iteration as well, because it's quite an important topic. So that's it. So in this video, we've looked at collecting like terms, so deal with each of the letters separately, to deal with the x's, then deal with the y's, and so on. Expand in brackets, make sure you can expand a bracket, 2 brackets, even 3 brackets. Factorizing, so make sure you're able to factorize and factorize quadratics and use differences to squareds and be able to factorize harder quadratics and so on. Algebraic fractions, make sure you're able to simplify your algebraic fractions by factorizing and cancel down. Adding algebraic fractions, just like adding fractions really, but just obviously with algebra involved. Multiplying and dividing algebraic fractions, so again, similar to what you would do for multiplying and dividing fractions, but just with algebra involved, and just make sure you're cancelling down. Make sure you can find the nth term of a sequence. Make sure you can find the nth term of a quadratic sequence. So in terms of that, I would find the first differences and the second differences. The second difference would be equal to 2a. The first difference is equal to 3a plus b, and the first term of the sequence is equal to a plus b plus c, and that's quite useful for that. Substitution, make sure you can substitute values into expressions and so on. Equations, make sure you can solve equations with letters on both sides. Also harder equations, and also equations where you have to form them first of all, perhaps with angles or perimeter or ages and things like that. And make sure you can do change in the subject questions. And I like these because they're just a bit like solving equations, but you just don't need to work anything out. Also make sure you can do the harder ones wherever you may have more than one of the same letter. So then you'd perhaps have to factorize, and then you'd then get that letter equal something. Also know your inequalities. So make sure you know how to solve inequalities, represent inequalities on number lines, and so on. Make sure you can do your graphical inequalities. So draw the graphs and then make sure you know which region would satisfy those inequalities. Quadratic inequalities, I would sketch the quadratic graph first of all, and then find where it's above the x-axis or below the x-axis and just write that down. Linear graphs, know your y equals mx plus c, so m is the gradient and c is the y-intercept. Make sure you know how to draw those linear graphs, and you can either use that y equals mx plus c to help you, or use your xy tables. Know how to find the midpoint of 2 points, so do add them together and then half it. Make sure you know how to find the distance between 2 points using Pythagoras' theorem. Also make sure you know how to approach questions that involve those real life linear graphs, and know what the y-intercept represents, that set figure, set amount, and what the gradient represents, perhaps the daily charge and so on. Parallel lines, so there are lines where the gradients are the same, and perpendicular lines are lines across each other at 90 degrees, and if you know the gradient of one, do the negative reciprocal to find the gradient of the other one. Make sure you can solve your simultaneous equations, perhaps by cancelling out a letter, and once you find what one letter is, then substitute that in to get the other one. Non-linear simultaneous equations, if it's both y equals and y equals, just put them equal to each other. Alternatively, make x or y the subject and substitute it into the other one. Graphical simultaneous equations, make sure then you know how to draw those, so draw the graphs and find where they intersect. Equation of a circle, x squared plus y squared equals r squared, where the center is the origin and the radius is r. The equation of a tangent, so find the gradient of the radius, do the negative reciprocal to get the gradient of the tangent, then you know it goes through the particular point, then use y equals mx plus c and put that point in and then find your c. Instantaneous rates of change, well, just draw a tangent at that particular point and find the gradient of that tangent. Average rate of change, the 2 points that they're talking about, join them up with a chord and find the gradient of the chord. Area under a graph or area under a curve, we'll draw the strips and then find the area under the curve, finding the area of each of those perhaps triangles, or maybe that they are trapeziums and so on. Composite functions, so if for instance you're working at fg of x, you're going to apply function g first of all, get that and then substitute it into function f, and then that would give you fg of x. Inverse functions, so what I would do is I'd let the function equal y, and then I would make x a subject, and then that would give me the inverse function, just change the y with an x at the end. Quadratic graphs, make sure you know how to draw them, sketch them, find the coordinates of the minimum point, maximum point, the lines of symmetry, and so on. Solving quadratic graphs graphically, so making sure you know how to find the roots of a quadratic using its graph, so that's where it crosses the x-axis. Also, if you've got the quadratic equal on a certain number, then draw a horizontal line at that number and find where they intersect. If you've got the quadratic equaling perhaps a linear, then draw the linear and find where they intersect, and so on. Sketching quadratics, so make sure you know how to sketch quadratics, and we talked about that with our quadratic inequalities. Trigonometric graphs, know the graph of y equals sine x, remember that goes through the origin, 91, 180 degrees and 0, 270 minus 1, 360 and 0, and so on. The graph of y equals cos x, that starts at 0, 1, and then comes down and up again, and so on. And the graph of tan x, so obviously it starts at the origin, goes upwards, and it's got asymptotes at 90 and 270. Know what the cubic graphs look like. Know what the reciprocal graphs look like. So in terms of reciprocal graph, remember it looks something like that. Know what the exponential graph looks like. So if you get the exponential graph, if it's a value that's bigger than 1, it would look like this, and then it would curve upwards very quickly, and it would pass through the point 0, 1. Geometric sequences, so there's sequences where we're multiplying each time, so we might be multiplying by 2 or by 3 or by 4, even by a quarter or a fifth and so on, so it might even be getting smaller. And just also remember that if you divide a term by the previous term, that'll give you what you're multiplying by, and if it's got algebra involved, that can be quite useful as well. Algebraic proof, and if you're using even numbers, I would let that be 2n, an odd number would be 2n plus 1. If you're dealing with even numbers, I would let that be 2n, odd numbers, 2n plus 1. Make sure also you know what the term consecutive means and so on. If you need to show something's a multiple of a certain number, then at the end you want to factorize and take that number out. The quadratic formula, it's given to you, but it's x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. The coefficients, the number in front of the x squared is a, the number in front of the x is going to be your b, and the value on the end will be equal to c as long as it equals 0, and then you substitute those in. Completing the square, know how to do completing the square. Transformations of graphs, know the 4 different transformations that you need to know. The minus f of x is a reflection of the x-axis, f of minus x will be a reflection of the y-axis, f of x plus a, where the a, as I said, the brackets would move the graph a squared upwards, and then f of x plus a, where the plus a is in the bracket, would translate the graph a squared to the left. And iteration, make sure you know how to use those iteration formulae, and that's it.
And that's it. So in this video, we've done a recap of the algebra topics. Now we've gone through the number topics, we've gone through the statistics topics. Today we've gone through the algebra topics, and tomorrow we'll go through the geometry or the shape, space, and measure topics, and we'll look at those tomorrow. And that's it. So thanks very much. I really hope you found this video useful, and you've got 3 days to go. Keep up the hard work. You're going to do really well, and I'll see you tomorrow. Cheers. Bye.